Okay, let's just dive right in. We are going to tackle a question that you've probably never actually asked out loud, but come on, I bet it's crossed your mind at some point. We're going to explore the fascinating and, let's be honest, kind of ridiculous science behind preserving one of nature's, well, most fleeting creations.
I mean, seriously, have you? Is it even possible to capture that ephemeral moment and save it for later? It really does sound like a joke, but from a scientific standpoint, it's a surprisingly difficult puzzle to solve. And today, we're going to break down exactly why that is.
So, right off the bat, you can't just trap it in a mason jar and call it a day. Nope. The very nature of what we're trying to preserve makes this a huge scientific headache. Let's get into the core of the problem here. See, a fart isn't just one thing. It's this complex cocktail of tiny, super volatile gases. We're talking sulfur compounds, the things that give it that signature aroma. These molecules are incredibly small, so they can literally just sneak through the microscopic pores of most containers. Plus, they're highly reactive, which means they're just itching to break down and change into something else as fast as they possibly can.
Okay, so given that challenge, how would a scientist actually do it? Let's start with the first approach, the one that requires perfect, meticulous, laboratory-level control. This method is all about precision. First, a Ziploc bag is not going to cut it. You need something special, like a Tedlar gas sample bag, which is engineered to be totally non-permeable. Next, and this part is absolutely critical, you have to get rid of all the oxygen. Oxygen is the enemy here. It just loves to react with and destroy those smelly compounds. So you'd either suck all the air out to create a vacuum or flush the bag with an inert gas, like nitrogen. And finally, you'd freeze it. I mean, deep freeze it. The extreme cold slows down all those chemical reactions to a crawl, basically putting the gas molecules to sleep. All right, so the lab method is a lot. It's pretty intense. But what if you don't have all that fancy equipment just lying around? Well, it turns out there's another way, a pretty clever approach that uses some basic chemistry to create a kind of molecular trap. The key to this whole method is something called an adsorbent material. And the best example out there is activated carbon. You can think of it like a super sponge, but on a microscopic level. It has this enormous surface area that's just packed with countless tiny pores and crevices, which are the perfect size and shape to just grab onto and hold those little odor molecules. The way this works is actually beautifully simple. You'd release the gas into a sealed container that has activated carbon inside. That carbon immediately goes to work adsorbing the odor molecules. And that's adsorbing, not absorbing. It means the molecules literally just stick to the surface of the carbon, effectively trapping the scent on a solid material instead of letting it float around. So let's put these two methods side by side. How do they stack up? Well, the lab method is the gold standard, for sure. It preserves the pure, actual gas sample. But it's really complex, and you need special gear. The chemistry method, on the other hand, is way simpler and more accessible. The big trade-off, though, you're not actually preserving the gas itself. You're just trapping the scent molecules on a solid. And even then, they're still going to break down eventually. So whether you're trying to build a home lab or you're just, scientifically curious, this whole quest boils down to three absolutely essential principles. You could call them the fundamental rules of the game. These are your three golden rules. If you want any chance of success, you have to follow them. Number one, you need an excellent, truly gas-proof container, no leaks. Number two, you have to get rid of all the reactive oxygen in that container. It's just poison to your sample. And number three, keep it in a cold, dark place. The cold slows down the reactions, and the dark, well, light is energy, and it can also help break down those delicate chemical compounds. Okay, so after all this science, the special bags, the vacuums, the activated carbon, what's the final verdict? Can you actually pull this off for any meaningful amount of time? Well, we've arrived at the inevitable truth. And there you have it. That's the definitive answer. Even with the absolute best methods we have today, preserving such a complex, unstable gas for years is considered practically impossible. The molecules are just too determined to break down, change, and disappear forever. So for now, it seems the case is closed. A fart is, by its very nature, a fleeting moment in time. But it does make you wonder, doesn't it? As our technology for molecular containment and stabilization gets better and better, could we one day crack the code? Could we actually turn today's scientific impossibility into tomorrow's very, very strange reality? Now that is something to think about.